We are going to solve quadratic equations including trigonometric ratios. Look at this example. We will solve part B. Solve for theta in the interval where theta is between 0 and 360 degrees. The equation sine squared for theta minus 30 degrees is equal to half. This is a quadratic equation because we have sine squared. However, it is the simple kind of quadratic equations that doesn't need factorization. The form is x squared equals to k, not ax squared plus bx plus c is equal to 0. If k is positive, then directly we can say x is positive square root of k, or x is negative square root of k. So here, sine squared for theta minus 30 equals to half. The half is the k and it is positive. So the sine is positive or negative square root of half. However, now we want to replace the existing angle, which is theta minus 30 degrees. So we say, let x be theta minus 30 degrees. Be careful that theta is between 0 and 360 degrees. Now we subtract 30 degrees from each side. Minus 30 degrees less than or equal to x less than or equal to 330 degrees. Now we replace the angle. Sine squared x equals half. Sine x is positive square root of half, or sine x is negative square root of half. Therefore, x is sine minus 1 for the value of this. We distribute the square root on the numerator and denominator to have plus 1 over square root 2, or x is sine minus 1 for minus 1 over square root 2. Now we will use the calculator. Always be sure of the unit. Here it should be in degrees. Okay, so shift sine plus 1 over square root of 2. The answer is 45 degrees, and this is the first value. 45 is within the range. Or x is, you simply insert minus 1 instead of plus 1. The answer is minus 45 degrees. This angle is not within the interval given, so we need to change it. Let's represent them on the quadrant plane. X is 45 degrees, so here. The second one is minus 45 degrees. It doesn't exist. So we need to represent it in a way where it is less than 330. All of this is 360. And we subtract 45. So angle x is 315 degrees. It represents the angle and it is within the interval. As you can see, these are the basic angles. The first one is 45 and the second one is 315. To find the remaining angles, we need to look at all the other cases which will result in 45 degrees. And we also want the sign to be positive. It is positive in the second quadrant, where this angle is 45 degrees. To find this angle, it is 180 minus 45 degrees. The value of x is 135 degrees. So now the x has 45 and 135 where the sign is positive. When the sign is negative, the first angle is 315 degrees and we need to find the second angle. Here the sign is negative, which is in the third quadrant, and the angle is 45 degrees. All of this is 180 and we add the 45 degrees. So 180 plus 45, the second angle is 225 degrees. As you can see, the four values of x are within the interval. Remember that we are solving for theta, so now we need to substitute. Let's write the given. When sine x is equal to positive square root of half, the x is 45 degrees and 135 degrees. When sine x is equal to negative square root of half, the x is 225 degrees and 315 degrees. Now we need to calculate the theta for each one. X is theta minus 30 degrees, so theta is x plus 30 degrees. Let's substitute. Theta is x, which is 45, plus 30 equals 75 degrees. Here, x is 135 plus 30, which equals to 165 degrees. Now here, x is 225 plus 30, it equals to 255 degrees, and finally 315 plus 30 equals to 345 degrees. So these are the four values of theta: 75, 165, 255, and 345 for this quadratic equation, such that they are between 0 and 360 degrees. You can solve these exercises in the same way, and you have different forms. For example, cosine squared is equal to constant, or it could be ax squared plus bx plus c. Here you need to factorize, then you need to find the exact value of the angle which results in this equation.